Good day to all of you. Myself, Dr. Arvind Sharma, Associate Professor in Physics, Government Dugar College, BIKANER. Today we are continuing the topic satellite, and we are trying to understand the general background of satellite. A satellite is a moon, planet or machine. It may be moon, planet or machine that orbits a planet or a star. For example, Earth is a satellite because it orbits the sun. Likewise, the moon is a satellite because it orbits Earth. Usually, the word satellite refers to a machine that is launched into space and moves around the Earth or another body in space. Okay, satellite is a device which is launched in space and moves around another object on Earth. Earth and Moon are natural satellites, as we already understand tomorrow. Thousands of artificial or man-made satellites orbit Earth. Some take pictures of planets that help meteorologists predict weather and track hurricanes. Some take pictures of other planets, the sun, black holes, dark matter, or faraway galaxies. These pictures help scientists better understand the solar system and universe. Still, other satellites are used mainly for communications, such as beaming TV signals and phone calls around the world. A group of more than 20 satellites make up the Global Positioning System. A group of more than 20 satellites. You all know the word GPS, that is Global Positioning System. Global Positioning System. If you have a GPS receiver, these satellites can help figure out your exact location. You all, maximum students know about this through their mobile. Why satellite important? Why satellite important? The bird's eye view that satellites have allows them to see large area of Earth at one time. This ability means satellites can collect more data more quickly than instruments on the ground. That is the main important argument or background due to which satellites are important, because they allows to see large areas of Earth at one time. Due to this, its ability enlarge and they collect more data more quickly with respect to ground instruments. Satellites also can see into space better than telescopes at Earth's surface. That's because satellites fly above the clouds. Satellites fly above the clouds. Dust molecules in the atmosphere that can block the view from ground level. Before satellites, TV signals did not go very far. TV signals only travel in straight lines, so they would quickly trail off into space instead of following Earth's curve. Sometimes mountains or tall buildings would block them. Phone calls to far away places were also a problem. Setting up telephone wires over long distances or underwater is difficult and costs a lot. With satellites, TV signals and phone calls are sent upwards to a satellite. Then almost instantly the satellite can send them back down to different locations on Earth. So how Satellites are important for TV signals and phone calls also. What are the parts of satellite that we already discussed? This is that article is quite different approach. Both articles are written by different persons. Satellites come in many shapes. You can understand what is the difference between 2 and 3 and other books if you compare the article, because every person when they write there is some difference of their approach, and by reading the different books and different articles your knowledge enriched. Okay, satellites come in many shapes and sizes, but most have at least two parts. In last part we see that there are 4 parts. It is only showing 2 parts: antenna and power source. Antenna, we know about what is the role of antenna: send and receive the information often to and from Earth, and the power source can be a solar panel or battery. Solar panels make power by turning sunlight into electricity. How do satellites orbit Earth? Most satellites are launched into space on rockets. A satellite orbits Earth when its speed is balanced by the pull of Earth's gravity. A satellite orbits Earth when its speed is balanced by the pull of Earth's gravity. Without this balance, the satellite would fly in a straight line off into space or fall back to Earth. Satellites orbit Earth at different heights, different speeds, and along different paths. The most common type of orbit are geostationary and polar. Polar and geostationary orbits are commonly used. A geostationary satellite travels from west to east over the equator. It travels west to east over the equator. It moves in the same direction and at the same rate Earth is spinning. It moves in the same direction and at the same rate Earth is spinning. From Earth, a geostationary satellite looks like it is standing still since it is always above the same location. Polar orbiting satellites travel in a north-south direction. Polar orbiting satellites travel in north-south direction from pole to pole. As Earth spins underneath, these satellites can scan the entire globe one strip at a time. Why do not satellites crash into each other? Okay, actually they can. NASA and other US and international organizations keep track of satellites in space. Collisions are rarer because when a satellite is launched, it is placed into an orbit designed to avoid other satellites. But orbits can change over time and the chances of crash increase as more as satellites are launched into space. Okay. What was the first satellite in space? We know Sputnik. Sputnik first was the first satellite in space. The Soviet Union launched in 1957. What is the history of NASA satellite? How does NASA use satellites today? Few small questions. What is an orbital satellite? An orbit is a regular repeating path that one object in space takes around another one. An object is an orbit is called a satellite. A satellite can be natural like Earth or the Moon. Many planets have moons that orbit them. Planets, comets, asteroids, and other objects in the solar system orbit the Sun. What are the different types of satellites? Satellites can be classified by their function since they are launched into space to do a specific job. The satellite must be designed specifically to fulfill its role. There are 9 different types of satellites, that is, communications satellite, remote sensing satellites, navigation satellite, LEO, low Earth orbit, medium Earth orbit, like that, LEO, MEO, HEO, GPS, global positioning system, and geostationary satellites, drone satellite, ground satellite, polar satellite. Communication satellites are artificial satellites. They receive signals from an Earth station and then retransmit the signal to other Earth stations. They commonly move in a geostationary orbit. A remote sensing instrument collects information about an object. Communications satellite, remote sensing satellite, navigation satellite, geocentric orbit type satellites. These are geocentric orbit type, LEO, MEO, and HEO. Global positioning system, GPS, global positioning system. Geostationary satellites, drone satellite, ground satellite, polar, nanosatellites, CubeSats, and small sats. How many satellites are currently orbiting? Right now there are nearly 6,000 satellites circling our teeny planet. About 60% of those are defunct satellites, space junk, and roughly 40% are operational. Only 40% are operational. As highlighted in the chart above, the Union of Concerned Scientists UCS determined that 2,666 operational satellites circled the globe in April 2020. What is satellite? Explain. A satellite is a moon, planet, or machine that orbits a planet or star. Usually the word satellite refers to a machine that is launched into space and move around each and another body in space. Earth and the moon are examples of natural satellites. Thousands of artificial or man-made satellites orbit Earth. What is a satellite called? What is a satellite called? Earth is a satellite because it moves around the sun. The moon is satellite because it moves around the earth. Earth and the moon are called natural satellites, but usually when somebody says satellite, they are talking about a man-made satellite. What is satellite and types of satellite? A satellite is a body that orbits around another body in space. There are 2 types of satellites, natural and man-made. Example, natural satellites are Earth and Moon. How satellite works? A satellite basically self-contained communication system with the ability to receive signals from Earth and to retransmit those signals back with the use of a transponder, an integrated receiver and transmitter of radio signals. A satellite has to withstand the shock of being accelerated during launch up to the orbital velocity of 28,100 km an hour and a hostile space environment where it can be subject to radiation and extreme temperatures for its projected operational life, which can last up to 20 years. In addition, satellites have to be as the cost of launching a satellite is quite expensive and based on weight. To meet these challenges, satellites must be small and made of lightweight and durable materials. They must operate at a very high reliability of more than 99.9% in the vacuum of space with no prospect of maintenance or repair. This is in tail set 6th. The main components of satellites are explained here again. Okay, so these are the general information about your satellites: low Earth orbit, geostationary, and what are the heights of these satellites. These are explained here. You can easily understand about it. Information is given very explanatory. Satellite applications, how satellite works. So you just go through this article. So your general information about satellite communication or satellites is enriched and what are the applications of it. This is the part in which a general reflecting this is explained how it is worked. Parabolic satellite dish antenna. Okay, so in next lecture we start with our topics orbital satellites. Okay, thanks to all of you.